Good afternoon, this is Schweitzer, and here's a short little video on Introduction to Projectile Motion. Now, projectile motion is any time that we're going to be throwing something. So, there are basically three ways in which we can throw something, and we'll talk about examples and how to solve problems for each of these types. First type, obviously, is just to throw something, straight up. So when I throw something, we've actually done these problems already. We'll just throw something at a certain velocity straight up. And then of course it just comes straight down, and there's not a whole lot of problems you can solve with this other than to know what's your max height. Um, you could find the height at certain times. Um, you could find the velocity at the end. And of course, energy is actually a nice way to solve a lot of these problems. Kinetic and potential energy. All right, what about straight horizontal? Okay, well, in this case is a situation where maybe you're on top of a cliff and you just throw a ball straight off a cliff. Um, or you could, let's say, have a person fire a gun just straight horizontally, and you just go like that. All right. Or we could shoot something at an angle or throw a ball at an angle. Let's say you throw a ball at a certain velocity and at a certain angle, and of course it takes this sort of projectile motion, lands on the ground. So all of these guys, I mean, they all end up being somewhat different, but somewhat the same. We're looking for, possibly how far did it go? What's my max height? This one doesn't have a max height. It's just basically the second part of this projectile motion. So they're all a little bit different, but there are some commonalities between them all, and we want to focus on some of the commonalities so that we can not to memorize as much and can just problem solve a little bit easier. Okay. So first, we're just going to solve a couple of problems in a problem where we're just throwing it straight up. This is I would say, the simplest problem. Okay. Couple key things to remember as we're doing these projectile motion problems. The x velocity, horizontally, everything at some point has x velocity and a y velocity. These two velocities combine to form a resultant velocity. The two components, x and y, actually work independently of each other. The only commonality they have between them is time. They work in the same time, but other than that, they work completely independently. Now, in this problem where we're only throwing something straight up, there is only a y component, or you could say the y component is present and the x component simply equals 0. So just a couple general rules you want to be aware of. The x velocity controls how far you go horizontally. So for example, if you're throwing a rock off a cliff, which is the next problem we'll look at, then the faster you throw it horizontally, the farther it travels. And that's it. The x velocity controls how far horizontally you travel. That's often called range. The y controls how long you're in the air. This is a very key point, and often is the very first thing that I want to find anytime I'm doing a projectile motion problem. How long will I be in the air? Obviously, the longer you're in the air, as you see written right here, the longer you can travel horizontally. So that is something that if you're in there longer, you'll have more time to travel horizontally if you're traveling horizontally. And finally, the y component also is going to give us our maximum height. So, for example, if you're throwing a ball straight up, obviously, the harder you throw that ball straight up, the farther up in the air it's going to go, and the longer it's going to be in the air. So these are two things that we're going to want to try and focus on, and I can't stress enough. Y component how long you're in the air. That is typically one of the first things I want to solve for in any projectile motion problem. Okay. Now, a couple of things here. One, this is an XY data table. Okay. Typically speaking, whenever I'm looking at solving a problem, I'm looking at velocities, distance traveled, and a distance formula is one of the main things I'm looking to solve. So distance equals xi plus vit plus 1/2 at squared. So along the side here, I'm going to list out all of these variables. So distance, you could put xi if you'd like. Vi is your initial velocity, your acceleration. Now again, if all of these guys that I'm mentioning, x is different than y. You'll have a velocity in the x, you'll have a velocity in the y. All right? And then of course time. You could also have a velocity final. Sometimes we'll use that as well. Or we'll solve for it. Now if I have velocity final, I'm going to be using this formula. Vf equals Vi plus AT. Now, a lot of times, instead of X, I put X, S, I put XT. That's the position at time t. Just like here, VT. This is a velocity at time t. All right, so let's just start putting all these things in here, okay? Now, X literally has nothing. We're not changing anything horizontally X-wise. So I'm going to focus mostly on the Y here. Now again, the S is actually X. Now again, X means we're running up and down a line. So where are we position-wise on a line at a certain time? Because I'm in the Y, the formula quite still says XT. My line just went from horizontally to strip it down. So you call it YT if you wanted to. But it's just on this line, up and down, where am I, which is position X, at time t. At xi, that is x. You could also call it x0 at where am I at time 0 or initially. So either way, xt is my location at a certain time. All right. So I don't know this initially. I could say, for example, where I'm ending up xt, I don't know the time yet. So xi is going to be 0. Let's just say set at 0 time. Initial velocity. Now this is the velocity in the y direction. I'm throwing it straight up, so it's going to be 15, which is presented in the problem here. Ball's thrown up at 15 meters per second. All right, acceleration. Now again, I'll draw a line here. Every time we're in the y direction and we're in free fall or in active gravity, it's the acceleration of gravity, which is negative 9.8. Negative. And this is acceleration of gravity. I want to remind you, acceleration of gravity will never take place in the x direction. All right? That's can have other accelerations in the x direction, but never gravity. Only y direction. Gravity can only work in the y direction. All right, time. I don't know the time yet because I haven't really started a problem yet, but I'm just going to say for you sure that whatever has that being x time is also the y time. Velocity final, depends on what time we are. So velocity final is just velocity at some time t. Now, what I'll point out to you, velocity at times t, is I'm going to shoot my ball up. Okay, this is stuff we've already dealt with, but it's at 15 meters per second. Just so you know some stuff about velocity. It's going to go up to the peak, and the velocity at that point is going to equal 0. And then it's going to come back down. All right? And at that point, I'm going to have the same velocity going down as I would have up, which is going to be a negative 15. So a couple of things to keep in mind as I'm going up. Every point upward is the same velocity as the point on the downward. If I'm going up here at x velocity, I'll be coming down at x velocity. Okay, so either way, let's try a couple of problems here just to kind of see how this is working out here. So first things first, it says, how long am I in the air? This is a common problem that we would almost the very first thing we would always look at. Turns out that in this problem, it's not nearly as needed. Okay, so We'll figure it out, but so let's take a look at and solve a couple things here. Um, this we can figure out, okay? You should be aware that the same amount of time it takes to go up is what it takes to come down. So if you know the time it takes to go up, you can just double it because it's going to take the same amount of time to come down as long as you don't hit terminal velocity. All right, so how long am I in the air? How do I figure that out? Okay, now in this problem, this might be review. Let's work through this again. Extend the page here a little bit. All right, what do I know about this? Well, I know that I'm starting up at 15 meters per second. I know that my acceleration, I'm going to give myself my table again here. All right, I'm in the y direction. All right, so distance, so acceleration is negative 9.8. So every second I'm in the air, I lose 9.8 meters per second. I know that at the very top, my velocity is going to equal 0. I'm going to use that to my advantage here. Okay, so VF equals VI plus AT. All right, so at the very top, I've already spent half of my time that I will spend in the air to get to the top. Another half of the time I'll spend to get to the bottom. Okay, so VF equals 0. My VI, as stated in my problem, is 15. Everything here is in the Y component. The acceleration is negative 9.8. Here's my T. How long am I in the air? I don't know, but this is going to give me half of my time in the air. So subtract the 15 off and divide the 9.8 by it. So it's going to be negative 15 divided by 9.8. And this is going to tell me how long it's going to take for me to get to a 0 velocity, which is the apex or apogee of my particular flight. And this is going to be a 1.53 seconds. Now, if I happen to be traveling horizontally, that the y doesn't care. The y has no care in the world about the x position. All I know is if I'm traveling horizontally, I'd be traveling at that velocity for 1.53 seconds, and I would travel that distance that I could get in 1.53 seconds. All right, so times 2, and I'm going to get, what, 3.06 seconds is the maximum time that I'm going to be in the air. So if I'm traveling horizontally, then I would have 3.06 seconds to travel horizontally. And the x would have no care in the world about how hard I'm off the ground, just traveling horizontally. And x and y work independently. Okay, so at this point, let's take a few moments here and look and see what we got. All right, other questions that are commonly asked. Okay, what's my maximum height? How far did my ball travel horizontally? We're not traveling 0 horizontally. What's my maximum height? Okay, to solve for maximum height, again, the x controls horizontal movement, y controls time in the air, which we just used, and your maximum height. Okay, so I want to use a position at time t. So it doesn't matter what I have, as long as I put my t in, it's going to give me my location at that time. Okay, so xi plus vi t plus 1/2 at squared. All right, so I want to find this location at a time when I happen to be at my max height. Well, initially I'm at 0. Initial velocity is going to be, let me erase that for a second. Okay. All right, so my initial velocity is 15. My time. Again, I can pick any time I want. If I pick time 0, then I'm at the 0 time, I have the 0 height. But I want the maximum height. 1.53 is my maximum height. Plus 1/2 at squared. Now this is negative 9.8, and my time is 1.53 squared. Now again, mathematically here, don't complicate things too much. Alright, do the math for this guy first. 15 times 1.53 equals 22.95. 22.95. This component's going to be negative because I have that negative right there. So it's going to be 1.53 squared. And then I'm going to multiply that times 9.8 times 0.5. It's going to give me a negative 11.4. Okay, if you want a 7, there you go. Add that to my original 22.95, and I get, looks like 22.95 minus 11.47 is 11.48. So just happens to be right in the middle. So it doesn't guarantee to be that. This is double that. That's not always the case. Either way, so the xt is equal to 11.4 meters. 11.40 meters. And that's my maximum height. Only reason why it gave me my maximum height is because I picked the time that it's at the maximum height. If I pick a different time, then it's going to give me the height at that alternate time. Okay? And that's pretty much it. How long are you in the air? We solved for that already. What's your maximum height? Or really, what's your xt at any time? Those are some common problems that we would use for throwing something straight up. We've already done the impact velocity is the same as it took off with, which is 15. You could, of course, say, okay, I'm going to be in the air. If I throw the ball up at 15 meters per second, it goes all the way to the top, and then it stops. All right, and then it drops all the way down. Okay, so right now it's 11.4 meters off the ground. 11.4 meters. That's the maximum height. If I have a guy who's on a ladder or a cliff and drops a ball at the same point and they both start falling down, that's exactly the same. And I could calculate the VF at the bottom, which would just be VF equals VI plus AT. So initial velocity at the very top is 0. All right, acceleration, negative 9.8. My time, well, I'm going to be dropping for 1.53 seconds. And if you do the math there, you should get 15 meters per second. It'll be negative only because it's going down. All right, so that's just a very basic introduction into our first type of projectile motion problem.